Hello everyone, Chris here again with another video. This one today is slightly different. I'm introducing something new to you. We have a new component and it is for volumetric modular. So what this tool does is it generates a full module complete with posts, beams, ties, joists, everything that you need for a volumetric module, allows you to configure it, and then distribute that to help you to build up your volumetric modular project. So let's jump straight in and let's have a look at it. So let's maximize that view, and you're going to find this tool in your applications components. Okay, so let's populate this model. Let's get one in here right now. So all we do is, let me do that again. We pick the starting point and then a second point. We aren't trying to dictate the length, we're just trying to dictate the span. Okay, and it's in the x-axis is your length. Okay, so it's the span of your unit. So we pick those 2 points and boom, you get your volumetric unit, and you can see you've got everything in there. So let's have a look a bit more in depth at the component. So if we double click on the unit, we bring up its dialog box. Okay, so the first page is your setup page. So this is where you're going to put the parameters in for your unit. Okay, so the length, I've got one in here at 10 meters, but obviously you can set that to whatever you need it to be, and this is the same for height and width as well. By default it's 3600, but we can reduce that to 3000 or millimeters, or 3 meters as most people would refer to it, in width, so 3.6 meters wide, and the height again, so we've got 3750. So that's the start height, which is this end. And we have, you'll notice we have a second module height set up here. That is to accommodate pitches in the ceiling cassette and the roof cassette. Okay, so if I go to a side view like this and I change this to 4 meters, you'll see that we get an elevation on this end, and we therefore have a pitched roof. Now you can do this in two ways. You can either do it by a known value here, by dimension, or you can set the roof angle. So if I set it to 2 degrees, it will increase that roof pitch and it will calculate the end height. So you've got a couple of ways to do it. But I can make that level just by setting that back to 3750, which is what I'm going to do for now, and leave it at that. Column extensions. So there is a bit of a difference in the industry that I've identified, and that's that some modular unit, some volumetric modular companies will have the members, the tie members, or the main beams bearing on each other, so they'll have a full bearing unit. Others will want some kind of an air bridge or a gap or whatever you want to call it between the ceiling ceiling cassette and the floor cassette, and this option allows you to accommodate that. So we can set the projection of the post above the top of the cassette there. We can also set it below as well, to any value that we like. I'm going to leave the columns at the top at 0, so they are level. The main assembly details. Now I'll talk about this in a bit more detail in a separate topic, just to explain what this means. But effectively what you're getting with this tool is a multi-hierarchy assembly. Okay, so that means that the top level assembly is the whole unit. Okay, so Tekla recognizes that as one assembly. Okay, so that one assembly is the naming or the numbering for that main assembly is dictated here. I say, okay, so your module name might be module 101. Okay, so it's the first module on the first floor. Okay, maybe something like that. And you might want your module marks to be the same. So you want the start number to be 101. Okay, so that means that any modules that you do following this one with the same start number will go 101, 102, 103. Okay, you can specify that, but that's how the numbering works. But yeah, I'll talk about the assemblies in a minute. Underneath that, you've got your column specifications. Okay, so this is where you set up the name and the class and the profile, etc., for your columns. And you can pick the profile very simply, hit the catalog button. That will bring up your profile database, and you can pick the section size for your column in there and then continue with that. So that gives you the facility to change the column section, and I think it's quite common to have a thick column at the bottom, a bigger column at the bottom on the bottom modules, and then thinner as you go higher up. But you can tailor that to suit whatever you need. So that's how you configure the main module. Then we need to drill down into the other hierarchical assemblies. Okay, so the next level assemblies are your ceiling and floor But before we get to those, we're going to have a look at the corner connections for the beams. Okay, so let's talk about those for a minute. So you've got two specifications here. You've got 1 times 3, which sort of describes a single connection that connects 3 members. Okay, so these tie beams, these main beams, and the column. Okay, so if you're a volumetric modular business that has a standardized prefabricated connection that joins those 3, you're going to use that specification to call in a custom component here, and then you'll use that as your connection. Okay, same thing at the floor connection, the floor cassette connection. The alternative to that is a 2x2. Okay, so you've got 2 connections that connect 2 pieces into one. Okay, so what that means is that you can control the connections of these 2 beams into the column independently. Okay, so we're going to do it this way. So the way to call in a component that you've got referenced in the catalog is hit this button. So that brings up the component catalog, and I'm just going to simply reference 103 for this example, which is a standard fin plate. So I'm telling Tekla that I want, or Tekla Structures that I'm using 103 for the connection of these 2 members, but I can change the specification based on having a standard file saved away in the connection. By standard file, what I mean, let me modify that. What I mean by that is if I go to connection 103, what I can do in this component is I can configure this for a particular connection. So let's say I want a connection that's got countersunk bolts. I can apply that, and then I can say that that is a standard countersunk connection. Okay, and now I've got that as what we call a standard file. Okay, so that's you can recall that at any point in your project. So if I bring this back up again and I go to the roof cassette, if we clear those out now, I can recall those in. So let me do that again. So 103, we pick the connection, and then over here I can say I want to use a standard connection. Okay, and then for the roof tie connection, I'm going to use the same component. I don't have to, but I'm going to. And this time I'm going to pick slim. And then when I modify that component, you'll see I've got 2 different connection types. All right, you don't have to use the same connection. You can use whatever you need to, but it allows you to control those separately. You do exactly the same thing down here for the floor. So if I pick that button there, just call in 103. But it's exactly just a repetition of what you saw before. 103 here as well. Let's pick that, and then we pick standard and we pick slim and we modify that. Okay, and then your floor joists are done too. Underneath that, you've got controls for the column connections as well. So on the column cap describes the detail at the top. So again, I can go into my library, and this time I can search by cap, and I can pick the cap plate detail, pick my standard file, hit modify, and that component gets applied. Again, you can use a custom component here. So if you're an organization that has a cap plate that maybe it's got a locating pin, maybe it's got a hole in the top or something like that, you can set up a custom component and reference that in here for that connection. Okay, it doesn't have to be a Tekla Structures library component. Similarly for the column base or the column foot, I recommend that you use 104.2 if you're not using a custom component, because this is the one that works the best. And I'm going to pick that as let's pick estimate. Let's just pick estimate. And that's going to put in a base plate for me there. Okay. Again, with 104.2, you might want to configure something like I have here with the base that is a bearing plate on that represents something that would bear onto the top of this column. But you know that's down to whatever your connection standards are. Moving on to the next tab, then I mentioned these sub-assemblies before. So as far as Tekla Structures is concerned, that roof cassette is a sub-assembly of the whole module assembly. Okay, so what that means is when you get to the drawings, you'll get individual assembly drawings. You should get a ceiling or a roof cassette, a floor cassette, and then a full module assembly drawing. Right, so you've got staged drawings for the assembly of the unit. So in here, we're going to be configuring that assembly. So the joist spacing is the first specification here. By default, the spacing is 600. So we can just set that there just to modify it and just to make sure. But you'll see that the closing gap is more than 600, and that's probably not what you want to see. So we've got this offset control here, ceiling start from center. So what that describes is the position of the joists against the centre line of that beam. So with true, you've got your joist on the centre line of the main bearing beam. If you switch that to false, what it will do is it will take the spacing of the joists, divide it by 2, and then position them equally about the centre line of the beam. Okay, so that's what you can see there, and we've closed that gap there. So probably compliant with what you want to see. Okay, so you've got that offset control for those joists. If for any reason that joist has to be on the centre line and you've still got this closing gap, you can use this option here to introduce a specific joist, okay, to close that gap up. So you can introduce an additional joist to close that gap up, but we're gonna distribute them evenly and leave it there. Quickly noting over on the right hand side here, what you've got is orientation controls for both the blue and the green beams. Well, the green beams in the floor equivalent, but for this tab here, this controls the orientation of the blue beam, and the roof tie controls the orientation of this orange beam here. Okay, so that's either toes in, toes out. So currently they're toes out, so if we change them both to inward, you'll see that they've changed orientation, now they're facing in. You've also got these plane offsets, okay, so this describes the offset relative to that column. So with the blue beam, I can offset that 20 mil, and you'll see that offsets in 20 mil, or if I express that as a negative value, it'll go the other way 20 mil. So that's going to allow you to align these beams with the column in any way you like. So whether it's the inside, the outside faces that align, or whether it's on the center line, those offset controls are going to allow you to achieve that. Going back over to the left, we see the assembly name. So again, this is controlling the assembly name for just the roof cassette. Okay, and then you've got the numbering controls as well. So you might want to call this roof cassette, and then you might want your assembly numbering to be RC and the start number 1, for example. Okay, and then that means that that roof cassette is called roof cassette, and when the numbering is applied, that roof cassette is RC1. So everything inside there gets RC1 referencing. Underneath there, you've got the same controls that you saw on the module setup for the column, except it's for all of the components that go inside this roof cassette. So the ceiling beams, ceiling joists, and the roof ties, you can specify all of the information here. One thing I do want to highlight here is the assembly numbering over here. It looks like a duplication, but it's different. Okay, so this numbering here is controlling the roof cassette assembly. What this one is controlling is the ceiling joist assembly. Okay, and what that means is that these joists are sub-assemblies of the roof cassette assembly, okay, because you have a joist with a cleat that might be welded or bolted to it. So you can control the joist numbering using these values here, okay, and equally you can control the joist connections using this line here. Okay, so I just want to make that crystal clear. Once you've got all of that, it's time to move on to the floor, and the floor is just a duplication of the ceiling. They work in exactly the same way. The only thing I'm going to add on there is those offsets. Everything else I'm happy with. Okay, well, apart from actually here, I will do this. So let's say it's floor cassette, and I'm going to prefix that FC, and I'm going to call that number 1. So we'll modify that. So once we've got all of that configured, we've got our unit configured, there are a few other tools that we can use to sort of embellish or build up this. So it's quite common for a volumetric modular unit to be filled out. And one of the first things there is walls, okay? And we have a tool here, framing panel tool, which you can use. It is designed for light metal framing, but it can be used to do timber elements. All you've got to do is change the profile. But very simply, you can introduce a light metal framing wall. So you dictate the span of it along the beam that it's going to sit on, like so, and that gives you your full panel. We have other videos on these panels. I'm not going to go into a great deal of depth other than to sort of show you how to very quickly configure it. So let's take a face-on view. You can see the thing doesn't fit very well, but using direct modification, I can just drag those edges and snap them all the way to the ends, so I can make it fit. Obviously, if you want a tolerance, you can offset that just to include that tolerance. I'm not going to worry about it too much in this demonstration. And the other thing you might want is some openings, so we can introduce some openings, but the smartest way to introduce openings to this is to use the contextual toolbar, which is this window here. So I can add an opening with a single point by clicking that button, picking a point, and that's going to put a doorway in for me, and you can see it's going to take the sill track out as well. Or we can use one of these other tools to introduce a window. So I'm going to use this rectangular opening to introduce a window, and actually I'm gonna for wow factor, I'm going to put it across the joint in the units. So if I pull up the component for this, you can see that our panel length is 3.5 meters. So basically that means every 3.5 meters we get the panel break. So you can see that's there. But if I put an opening across that panel break, it recognizes that and it configures both those panels to suit. All right, so I can put windows and doors in that unit very, very quickly. The other thing that I can do is I can put bracing in here. So if I use another component here, we've got tension and brace with compression bar. I have pre-configured it very slightly. So I've set the level at the bottom, the level at the top, and the section size, and that's pretty much all I've done. I can just pick these two columns and in goes a cross brace. Okay, very simple. Once I've got that, I can then select this entire assembly and I can start to copy that around. So I copy it up, copy it along in the y-axis, copy it in the x-axis to fill out my model, or I can simply just draw another module on the top. You know, so I can snap from sort of there to the other end, and then I get, you know, another module on top. So you can configure quite a lot very, very quickly with this tool. Okay, let's talk about the hierarchical stuff a little bit more in a little bit more detail. So we've got an example over here that I did earlier on, and to start to look at the information, I'll show you what I've done first. So I've called it module 101 and I've given it a prefix, and I've done the same thing for the ceiling and the floor cassettes. Okay, so to interrogate those, the first thing we need to do is we need to switch it to assembly selection so that you're selecting assemblies. Okay, when we pick on the whole assembly and we double click on it, we bring up the assembly information for the whole unit, and you can see what's happened here. It's bringing in the assembly numbering prefixes that I put into the component, and it's also bringing in the name as well. So if I want to look at the next level down, I need to hold shift and rotate my mouse button, and you should see down in the bottom here that number 0 has switched to 1. So that's saying I'm on hierarchy level 1. So now when I pick it, I should now only be picking the roof cassette, for example. Okay, and if I double click on that, I bring the information in for the roof cassette. So you can see how that information is being brought through, and the same thing for the floor cassette. And then if I roll that up to number 2, you can see that again down there, I can start to pick the individual assemblies, and that will go for the joist. So I can pick the joist assemblies, and we can start to look at those. All right, perfect. Hopefully you've been wowed by this little piece of innovation today inside Tekla Structures. If you've got any questions, you want to get your hands on it, you want a demonstration, or you've got any feedback on how the tool works or any applications of it, do give me a shout, leave me a comment either on YouTube or LinkedIn, because I'll be posting this on there as well. Or you can email me or any of the team, and we'd be happy to talk to you about applications for this. All right, this will be available very soon, by the way, on Warehouse. As soon as that's available, I'll share a link. Thanks very much for your attention. I look forward to your questions, and I'll see you next time.